So, 30 minutes on why containers are going to change your life and what you're going to do about it. So there are two of us here. There's me and Pratik, who's sitting over there. Because we only have 30 minutes, we're going to forego any of the demos. If you want demos, then after this, rush down to the IBM booth and we'll give you some demos of some of the stuff we're talking about. But otherwise, you're going to have to bear with us and it's just going to be me speaking. Okay. So, how does this all start? It starts here. Cloud. You remember cloud? Who's got a cloud? I have a cloud. IBM has a cloud. Hey. Cloud, it's what we've always wanted. Well, if you think about it, it's true. For a long time, prior to cloud, there was always this demand for getting out to cool resources off, and we put all sorts of effort in trying to build solutions that made it easier to provision things. And it was horrible. But we persevered, and now we have cloud. Okay? But it's not really cloud, that's just a nice name. It's this stuff, containers. It's all about containers. Whatever you consider a container is, it's all about containers. Why containers? Because you can take them anywhere, which is true. You can do anything with containers. These are real containers that people live in. Do you fancy living in a large metal box? Yeah, okay. You can do anything with containers. These are real containers that have been constructed into artwork. Isn't that cool? Okay. So you can do anything with containers. You can put them all together and go off in a completely new direction. You can create new voyages for yourself with containers. Yes. And as long as the answer is a container, we're done. So what containers have given us is a whole new flexibility in life. Okay, so we're now exploring, I'm sure you guys are all exploring new opportunities. So you've got your old story, which was the full stack, pick your favorite hardware operating system, Java version, app server framework, whatever. Traditional. You've got your monolith in a box where you take a chunk of it and go, it's a container. And then you've got your microservices where you have smaller containers. And then, of course, you've got more. You've got things like functions and tiny micro frameworks and functions down to, as we know, little tiny services, all in containers. And all of that lot running on some cloud. Yes? And the reason this is so important to us all are because of two things that we have been promised: immutability and repeatability. The promise is that if you put it in a container, nothing bad can go wrong, and that anything that you will do in a container will be the same wherever you run that container. Right? It's not quite true. There is a little bit of rain in our cloud, which we're going to talk about. So, going back to this chart, you want to enable all these things? What's the first thing you need when you've got lots of containers? What do you need? Well, you need a shipyard. Where do you manage your containers? All this stuff you're going to run, where does it run? And it runs on things like this, Kubernetes. So I imagine most of you guys are using Cloud Foundry, one sort or the other. How many people here are involved in looking in Kubernetes or something similar? Okay, cool. Lot more hands, that's good. So Kubernetes, Docker Swarm, PCA, whatever, you need a place to run your containers. And that's good. We can do that. And this then is the next thing, is when you've got your hundreds of thousands and millions of containers all running, you need loads of tools to manage them. We need good tools, don't you? So what's the tool story? As a Java programmer, I occasionally will go to Google and say, what are the top tools I should be looking at? And I get a list, and it might say top 5, maybe top 10. So if you do this for Kubernetes, what do you get? The top 50 useful tools. And I would encourage you to go Googling and having a look at this list, because you will probably, like I did, go through and go, yeah, actually they make sense. I understand why I need a lot of these tools. There is this list of useful tools, and unfortunately there's more than 50. So you think 50 is a high number? How about this lot? Anybody seen this picture before? Yeah. So the Cloud Native Computing Foundation tried to bring it all together and say, well, what have we got? And they ended up with this. This is all important tooling. There's just so much of it. So that's the first thing, a problem we have with the consequences of our desire to do containers is the tools that we need to manage this. Because if you imagine what we're doing, we're moving away from very simple setups. I have a little application, I build it on my desk, I get a WAR file or a jar file or whatever, and I get it pushed onto a server, which we'll talk about in a sec. But when you're in a container world and you're talking about high availability clusters, another level of complexity, and hence more tools. But it's more complicated than just the tool space. One other thing that we've realized, and we've all discovered, is that what you put in these containers doesn't necessarily behave the way that you think. And quite often we find ourselves in situations where the container is full of trash because something went wrong somewhere, right? And they just don't behave. And figuring that is hard. Debugging is really painful. I'm sure you know, debugging a container when it's behaving even intermittently, or even when it's not intermittent, but trying to debug it when it's in a cluster, it's hard. Yes. This is not a lot of people. These aren't people praying, by the way. This is actually some sort of yoga class, but we were doing this, well, these guys were doing it just before we did some stuff, and it's quite relevant. But anyway, so look, it's tough. Right, so choices. What do you pick first? Platform. You're a developer, pick one. Cool. Pick your favorite Java, as Gil was saying, just now. 9, gosh, that's really old. 17, isn't it? So 9, 11, whatever, your choice. And then pick your frameworks. Whatever framework you want, pick them all. And then you have a build cycle, because now you've got a choice about, do you pick Maven or Gradle or something else, and do you use Git or something else? These are all choices that you're making, that you have to make to get your job done. And then you add IDEs and tests and all that sort of stuff. So pick your favorite IDE, and pick your favorite test process, and your favorite database, and maybe some mocking things, you know what I mean? And then maybe some tools that you put into the IDE. Hey, that's your life. Is that recognizable? Many people go, yeah, I get that, right? That's life. But there's more, isn't there? Because this thing that you do on your desk, come on, aha. When you check your code into Git, this happens. Your CI system reproduces exactly what you did, well, not exactly, in its own way multiple times. Yes? That's life. This is what we have chosen. Right? And all of that to do whatever it was to put some application onto a mainframe or a server or whatever. Oh, by the way, that's life before containers. Because now we've got to add in more things like more frameworks and more languages, because we're not just writing in Java, we're writing in all these things, and we're picking all these different languages and frameworks, and they're all part of the application. And then you add the containers. So that thing you had on your desktop, now you've got a second version. So you've got, when you save it, Control S, and what you do when you build it locally, and then you've got your Docker container or your other container, which is you're building it inside that. Well, that's cool. So, and then you do the same on your CI/CD system, right? And the theory is that all of that works together so that you get an immutable image out the end that is intended to behave as the developer expected it to. The expectation is that developers, you as a developer, change your code, do whatever you do locally. For some reason, we assume that when your code's gone through this process, it'll end up doing exactly what we want, right? And the answer is we know that that's not true, right? Because the tools that we offer are heavyweight and complex, and they have got bigger and more complicated. So we tend to, as developers, to not use the tools that we run on big systems. We tend to run them different tools locally. All right? And the life cycle that we choose, tends to be quite complicated. We do things, so developers do a shortcutted version. And here's one of the killers. So much of the choices that get driven by this process start off from the code that you have in the developer in your hands. So a whole bunch of choices, metadata for your system can be held in a place where the developer can influence it. And that was always a good idea to start off with, but it's turning out to be part of the problem. So we ended up with this. What we have now is this situation where multiple opinions on what your build process does. Yes? So what the IDE thinks, Control S. What the full build process does, Maven install or package or Gravel or whatever it is. And then you do it in a container, right? And then you do it on your CI system and again, and probably on the CI system in a container. And then you do it again because you've got multiple staging. And then eventually, if you're really happy, you put it to production, and it works the same way that the developer thought, right? Containers have made our life much harder because we've added more steps, because we have to do these things to prove that things work outside containers and inside containers all through this process, which is ironic because at the end of the day, all of this stuff that we do is intended to ensure that what the developer does is as close to reality as possible so that we can get throughput. And we're all being sold on the idea that the cloud is here to help us deliver faster, but right now, because of the tool space, it's actually going the other way because we're having to deal with all this operational complexity, right? Which is just sad. Oh, and by the way, it's not just your life that's changing from a point of view of its more complexity, all the tools are changing, right? So the CI/CD system that you've used, probably Jenkins or Travis or whatever, yeah, well, that's going too. Because if you're delivering a high availability solution, you can't have the CI/CD system being the bottleneck. If your Jenkins server fell over, you couldn't deliver. So central servers are bad. So this model, where you have one central server and you have all these workloads coming through, build taking place, testing taking place, however complicated it is, and then shoving things out. That's not what you're going to end up with. That's not where we're going. The container space, cloud, clusters, the whole thing says, no, this isn't working. This is what you're going to get. Does anybody recognize Tecton or Jenkins as names? Okay. Good. We'll talk about those in a minute. The reality is that in a high availability solution, you can't have a single birds build server. So what do you have to do? You have pipelines that are also deployed to the cloud at the same time or related to your build process just for you. When I say you, the team, the developer, okay, so these Tecton, Jenkins X things or Kubernetes X, this is the life, new complexity. You don't have a build server, you have lots of little deployment pipelines that are part of your process, right? So that's interesting. And then one little bit more. Containers are so good that we're using them in the operating system. And containers are not just Docker, by the way. Obviously, you guys, a lot of you use Cloud Foundry, but wherever you look at it, it's a lot more. And again, I'll talk about that in a sec. But container Linux is an upcoming thing. CoreOS and others are looking at the fact that if you want immutability, you need to build your operating system, the server that you're running on, the server that our clusters are running on, not by doing anything like running scripts and things to set it up. No, it's got to be more immutable. So it's much more that you install containers onto an operating system. So a lot of the ways that we've been used to setting up systems are going to disappear because containers are driving us towards setting up systems using containers. So if you've said, oh, I've got a system and I want to put DNSs on it, or I want to put file servers, we're used to running things like maybe Apache on one of these things as a container, but this takes it further. All the services are going to be running that, okay? And these aren't things that you create and then configure. They are deployed with information at the beginning that says, here's what I expect you to do, and basically here's the list of the containers that I expect you to go get down and install. And it's pretty much like that. So this is where containers are changing our life in the other way, because anybody who's involved in a DevOps environment where you're using a lot of the traditional things like Chef and Puppet and Ansible and things like that, well, they are going to have to change to deal with these sorts of environments, because this is more immutable, more solid to do it this way than it is to allow you to fire up a server and configure it on the fly. Okay? So we're in quite a different place than we imagined. Much more complexity, many more new tools, and all of the choices that we've had about how we're going to work, whether it's a particular framework, a particular language, a tool, whereas you would just tend to pick one, now we pick them all. So we have all of that as well. Okay? So this talk really is about this problem here, which is just to let you know that life is changing, and right now the tooling space is not keeping up. The level of complexity is impressive. So a bit more rain than we were thinking. Okay. So, how bad is this? It's not all that bad, okay? Obviously, otherwise you wouldn't want me to leave and saying it's horrible. No, there's stuff happening. There's a lot of things happening. All right. One of the things to start watching, if we're not already, is the Cloud Native Computing Foundation, which is a group of people getting together to bring some sanity, right? Right. There are lots and lots of tools, and they need to work together, they need to have investment, they need to be curated, and that's what the CNCF is there to do. And they are providing nice little roadmaps, sanity about what do we have now, what do we need. Let's start laying those things out to produce some sanity in the tooling space. There's some really nice, interesting tools, some of which you will have heard of, and some of which you haven't, I'm sure, but we're trying to bring some structure. And things like the pipelines, so Tekton and Jenkins X are examples of new styles of build pipelines. So remember, build pipelines designed for one thing, not servers to do everything, but that path that you might draw through a line in a Jenkins build system, this job, imagine pulling those out and turning that into a pipeline. Okay? And these things run on the cluster where you run your containers. Okay? And I said about containers are more than Docker. Well, that's true. But what I actually mean is even the way that Docker is working, what Docker does is simplistic. And Docker itself, it's like this layered approach. There are more ways of doing it. And so there was a project called the Moby Project, which Docker is a part of, which is involving in standardizing what a container is in terms of an API and some thoughts about what you can do with it. And these guys are exploring new ways to create containers. Okay? You ain't seen nothing yet as far as what you can do with containers, right? Because it's now getting focused to say, what we've got is good, it's simplistic, we need to put some more thoughts behind it. So that's where we are so far. Now, but there are more, right? And I'm associated with this one. Okay, I'm a developer advocate for IBM. I do Java JVMs, but I do a lot more of the tooling space. So there's IBM, of course, as you can imagine, we're in this space and we care about this, and we would like to help bring some of the complexity down. And so there's a whole bunch of things that we're doing, and I'm going to talk about a couple of them. So obviously, and things with our new association with Red Hat, there's a lot of excitement around where are we going to do this? Where can we take the tools, invent new tools, reuse existing tools, bring them together and be part of this trying to reduce the complexity that is coming towards you. So let's talk about a couple of them. Eclipse Codewind is, how would I put this? Imagine you're a developer, you want to do something, and you go, okay, I need to do a performance test, or I need to do some workload testing. And you go, oh, I've got a tool. I've got my IDE, I want to install something. So I need to install it, I need to configure it, I need to point it at my container. And that any of you who've got involved in the wiring up of your development environment to talk to something you're running in a container knows how complicated that is. So Eclipse is trying to bridge that. Eclipse Codewind is trying to bridge that. It's very much trying to look at the point of view of going, those build steps, these different places where you've got opinions, or tucked inside that are all sorts of little tools or big tools that you're using, and many of them don't make it down to the IDE. So Codewind is saying, what can we do to facilitate getting tools that you might use on the server, something like that, down to you as a developer, but not as a, oh yeah, just go and install this stuff, but actually saying, let's wire it in and make it a discovery thing. So it's saying, if you have a container, it has a health endpoint, Codewind should be able to spot that and make available to you a tool to test your health endpoint. You want to do some performance work, Codewind should have that stuff. Making life easier and helping us get back to being able to use containers and debug and interrupt with containers the same way that we're used to interoperating with code that we're running on our desktop. Okay. So the other thing that Codewind actually does is those first three things, Control S, Maven build, and then maybe Docker build. Well, what Codewind is also able to do, and I would say this is sort of like a second thing, is because of this integration between containers and IDEs, is, well, actually that we can help reduce the number of build opinions only by a fraction, okay? So Codewind is trying to bring these things together and make it easy to discover and integrate. We should be able to work out what you're doing and give you the tools that you need. And eventually the idea is that when your experience with an IDE won't change, but everything you do with the IDE, Control S, there's an incremental compiler in your IDE, you might do a Maven build, all of that gets put into the container. And we integrate with that with your IDE. So you will not see the difference, you will just have a better experience. Okay. And then Absidy. Now, I love this one. It's a nice little command line tool, but actually I think this has some really good promise. And so let me just, so this set of build opinions, Absidy can do all of them, including Control S. And I'll talk about why in a sec. Because you know this thing I said, look, a lot of the thing is we put all the choices, not all of the choices, but very many of the choices into the code base. We give it to the developers. Okay? Absidy says you don't have to do that anymore. What Absidy does, and look, I'll try and get this to come up. Okay. Absidy gives you a stack. And in that stack, as you can see on the right, is a whole bunch of stuff, whatever you want it to be. And it gives you templates. And those templates contain some other part of the process. So typically, you might put tests and code in a template, and then put all the build tools that you need, dependencies in the stack. Okay? So imagine I have a build process that's containerized, and then I have templates which say there's only so much of the process, and so much of the code that I need is in a template. A lot of the code, some of the metadata will be out in the stack. You do Absidy init, that template code is put onto your desktop. So imagine that it's a template of here's how we would work. I press the button, I have that code on my desktop. And then when I start Rhapsody, it's going to run a container, and it's going to bring the code on your desk back into a container, including the build tools and whatever metadata that you have inside the stack, to give a virtual view just like you'd have on your desk. Right? But you won't be able to change the bits that are in the stack. You can only change the stuff that's on your desk. So you end up with a tool that's integrated with the IDEs that you can run everywhere, absolutely run everywhere, right, that brings together the that allows you to separate the metadata that you don't want to change from the code that you do. Okay? And you can then build these things yourself and share them within your teams. So you can construct environments that are basically how you want to work and allow you to separate out the concerns. So if you can do that, you can be much more confident that what you're running in each of these build processes, because you can do absolutely build, and I get a Docker image, I can run that everywhere and be confident that I've restricted what the developer can do, but I still give them the ability to create the system on the laptop. So look, and if I wanted to do this for Spring, well, I'd do something like this, right? And I'd put some code on my desktop, and I'd have the usual sorts of stuff, whatever it might be, and then I do this by hand at the moment. I'd make some decisions as to which bit I want to have in a template, which bit I want to have in a stack, and then I use the Rhapsody tools to build them. So I can have the same thing. So I can have this, think about this. I can give my developers the ability to work just like they normally use working, but I can take away from them the things that I don't want them to touch, right? Or I want to configure an environment that is specific to a particular team or a particular organization, and I can embed that into the stack. So I can get up and running really quickly. So I can use Spring Initializer to get going to create the structure that I want to share, and then all the developers got to do, okay, brand new developer, install Rhapsody, point it at your repo of this stuff, and go Rhapsody init local thing, and I now have a set of code that's tailored to my needs, plus a build process that's tailored to my needs, and that the bits that I don't want the developer to touch, right? And there's a whole bunch of IT operational reasons why you might want to do that, but also just to reduce the opportunity for the developer to break things, right? Is that you can provide that separation and bring it back together, and do that across the board. Every single part of your build process, including the integration of the IDE, you can replace with one tool that runs everywhere. Right? Now, it's early days for sure, because these are all brand new tools. These are all explorations. I think Rhapsody has a lot of possibilities for us, regardless of whether or not you buy into the rest of the stories. But actually, that ability for us to separate out the metadata that we care about from the code that we care about, because this isn't like, oh, I put my code here and I put my metadata here. I can go, if you want, we've got templates where we've got one file, Node.js, one file, that's the endpoint. Everything else is in the stack. So it's that easy to make those sorts of choices. So, a bit of a sales pitch, but it's an open source project. I'd totally encourage you to come and get involved in all of these things. We are exploring, just like everybody else is exploring, how we're going to get back to the equilibrium that we need based on the fact that the tooling space has just exploded. Now, we're trying to figure out how to make creating containers that work in all the right places, provide the tooling to give you the development experience back so you don't have to do things differently because you're doing things in container. The CNCF are desperately trying to give us some sanity into the tooling space and take those forward and get the developer experience back to where we had before containers turned up. That's it. I think I'm done. Thank you very much.